Okay, guys, so for Unit 2, we are going to start with a word problem and with a chart. You guys remember these charts? Yeah? So here's your problem. An elevator in a high-rise building moves upward at a constant rate. So just like you know with elevators, they don't shoot up and then sometimes go slow. They're always at a constant rate. The table shows the height of the elevator above the ground floor after various times. So at 0 seconds, the elevator is at 0 feet. That should make sense, right? It's on the ground. It hasn't gone anywhere. After 1 second, it has gone 12 feet. And after 2 seconds, it's gone 24 feet. So what does it look like is happening each time? Multiplied by 2. So after 3 seconds, how high would the elevator be? 36. Okay, what about after 4.5 seconds? How'd you get 45? How'd you get 50?
I got 54.
Okay, how'd you get 54?
I added 12 and then I added 6 more after that.
Okay, so Anthony said he added 12 and then he added 6 more. Why did you add 6 more after that? Because it's half of 12. So at 4 seconds, the elevator goes 12 feet more, but this is 4.5. So, or not, yeah. So after 4.5 seconds, it would also go an additional 6. So 54. So then how high would the elevator be after 5 seconds? 60. So we add 6 more to this. So can you guys write an expression for that? If let's say T is my time, if after 1 second I'm at 12 feet, what would you multiply 1 by to get 12? 12. What would you multiply, if T was 2, we had 24. What would you multiply 2 by to get 12? Or 24? 12. What about 3 times 12? Does that give you 36? So what might my expression be? 12t. Oh, yes. But it didn't ask us to write it as a function. We just have to write the expression. But you're right. Brittany said h of t equals 12t. That's correct. But it just wanted an expression, so we don't have to put it in function notation. Okay? All right, so the question is, what are the independent and dependent quantities in this problem? Let's start with independent. Guys, what's independent here? The amount of time the elevator is going up or the height of the elevator? What does the time, why the time?
Because this is the amount of time for that, so like you can control what for, kind of.
Yeah. The time is your independent quantity because the height of the elevator depends on how much time you spend in it, right? So however much time you spend in the elevator depends on how high it is. If the problem was saying that it takes 5 seconds to get to the second floor, 5 more seconds to get to the third, then you have control over what floor you go to, but we're just talking about the height. Does that make sense? We can assume that you can get off at any time, okay? So if the independent quantity is time in seconds, what would your dependent quantity be? Height in feet. Good. Okay. So the next question asks, what is the unit rate of change? What's the rate of change in this problem? 12. How do you know? Yeah, it's 12, what is it, feet per second. Because unit rate, unit, remember, means for every 1 second. But we know that every 1 second it goes up 12 feet. So your unit rate would be 12 feet per second. And then the last problem, or question about this one, says to use function notation. So that's what Brittany had originally said. To determine the height of the elevator at a time of 14 seconds. So let's first write this as a function. Brittany, what did you say the function was?
H of t equals 12t.
H of t equals 12t. So that's our expression written in function notation. And this time they give us a time. What time are we going to plug in? 14 seconds to T. So how would I write this?
H of T equals to 12, and in parentheses, 14.
Close. Remember, in function notation, whatever we substitute into the variable, we also write inside the parentheses. So it wouldn't be H of T, it would be H of 14. So that is just telling you what we're plugging in, okay? So H of 14 means that I'm going to plug in 14 for T equals 12 times 14, which equals what, guys? 168 what? Feet. So remember, with function notation, inside the parentheses means whatever you're plugging in. It doesn't have anything to do with how you solve the problem. It's just telling me as a reader that you plugged 14 in for T, and that's how you got 14 right here. Does that make sense? Okay. Example 2, I want you to solve for x. Here is your equation. 5 times x plus 4 minus 8 equals x plus 32. Okay, so when we were solving equations, the first step that we were doing was to distribute if possible or combine like terms. Do you guys see distribution anywhere? Yeah, where do you see it?
5.
Yeah, the 5. So remember, I always circle the number and then draw the arrows so that I remember that I'm multiplying. So what's 5 times x going to give you? 5x plus what? Plus 20 minus 8 equals x plus 32, because we didn't do anything to the right-hand side yet, right? Okay, so then before we start solving everything, let's combine like terms to make it a little easier for us. So what would 20 minus 8 be? 12. So plus 12 equals x plus 32. Okay, so now we kind of have a problem. I have 5x on the left, 1x on the right, and I want to get them both together. Can I just add them together? No, because they're on opposite sides of the equal sign. So how could I move that 1x to the other side? Good, subtract it. So subtract x from both sides. Because whatever you do to one side, you have to do to the other. So what would x minus x be? X minus x? 0, which is why we do that. And Anthony, 5x minus x gives me what? 4x. So we have 4x. We didn't do anything to the plus 12 yet. And we didn't do anything to the 32. Now to solve, I need to get all x's on one side and all numbers on the other. So I need to get rid of this plus 12. What would you do to get rid of plus 12? So subtract 12 from both sides, and that gives me 4x equals 20. And then what do you do next, Andrew? Okay, so how would you get the x by itself? And the inverse of multiplication is division. So we get x equals 5. How could you check your answer on this? Plug it in. So you take x equals 5 and plug it into the original problem. So example 3. Suppose that the elevator that we were looking at in the previous problem starts at the top floor of a high-rise building at a height of 372 feet above the ground floor. So that's our starting height. We're at the very top. It descends without stopping at a constant rate of 15 feet per second. And then part A wants us to write a function that describes the height of the elevator after t seconds. So we are using function notation. So it's going to be h of t equals, and then let's see what we can figure out. So remember, to write a function, we first want to start at where we are starting. Are we starting at a height, or are we starting at 0? We're starting at a height. What's the height that we're starting at? 372. So no matter what, we have to start at 372, but our elevator is descending. So is that going to be a positive rate of change, or is that a negative rate of change? Negative, so it's going to be minus, and what's our rate of change? 15t. So our function is 372, our starting height, minus 15t, because every second it decreases by 15. So then part 2, we're going to graph it. So I'll give you guys a second, draw your graph. So draw your graph. Remember, since we're looking at height, we are never going to go in the negative, so we can just do this. What's going to be our x-axis? Our independent quantity. Any guesses? Time or height? Time. So this is going to be time. And let's do every other as 5. So this is going to be 5, 10, 15, 20, and I think that should be good, 25. So that means our y-axis is our height in feet. Time is in seconds. I did not give myself enough room there. So time is in seconds. Let's see, our heights are go into the hundreds. So why don't we go every other one is 100. So let's do, so we'll count by 50. So 100, 150, 200, 250, 300, 350, 400. And then the last one would be 500. Okay. Okay, so let's start with our, let's start with our height at 0. So at 0, I forgot to label 0. At 0 seconds, what would our height be? 372, because we're starting at the top. So at 0 seconds, let's go to 372. So 300, here's 350. 372 would be somewhere in between 350 and 400, almost right in the middle. So let's plot another point at 15, or I'm sorry, at 5. That might be a little bit hard for us to plug in. So, but at 10 it might be a little bit easier. So if at 10 seconds, because this is 15, that would be 150, right? And what would 372 minus 150 give me? What'd you get? 222. So that's almost 225. So it's going to be somewhere right here in between 200 and 250. And remember, your graph is just an estimate. But how many points do we need to graph something? 3. Well, technically 2. But I always want you guys to do 3. So if we did 20, that would be 300, and 372 minus 300 would give me 72, so that's somewhere like right here. So let's draw a graph. Okay. And then the next question wants to know to estimate when the elevator is at a height of 200 feet. So using my graph, I want to know when our elevator is going to be at about 200 feet. So I'm going to draw a line at 200 feet. And that intersects about right here. About how many seconds does that look like, guys?
15.
Well, 15's here, 10 is here, so maybe like 12, 13. So let's say at about, I don't know, what do you guys think, 12 or 13? 12?
12 and a half.
Well, it doesn't have to be that exact. Let's just do 12. At about 12 seconds, the height will be 200 feet. Something like that. So we have to use a complete sentence. And then part D says to determine the exact time that the elevator is at a height. So if we're looking for the exact time, are we going to use the graph? No, we're going to use the function, right? So what are we going to plug in? Where are we going to plug in 200? Are we going to plug that into the time, or are we going to plug it into the entire height? Is 200 a time, or is 200 a height? It's a height. So we're not going to replace t with 200. We're going to replace the entire h of t. So that's going to be 200 equals 372 minus 15t, and we're trying to solve for t. So what would you guys do to get t by itself? Anthony, what would you do? Subtract 372, right? Because we're trying to get t by itself. What's 200 minus 372? Negative 172? Yeah. Equals negative 15t. And is this negative 15 being added, or subtracted, or is it being multiplied? It's being multiplied. So would I add 15 to get it to the other side, or would I have to divide by negative 15? So divide both sides by negative 15. And we would get t equals, negative divided by negative gives me a positive, which should make sense, right? You can't have negative time. So we get t equals 11.46666 repeating. So I would estimate to 11.47 seconds. Were we close? Yeah, our estimation was 12 and we got 11.47. That's pretty close. Okay, so example 4. I want you to evaluate the function f of x equals 31.572x minus 17.741 at each of these two values. So the first part is I want to find f of 6.2. Now we just talked about this. What does the 6.2 inside the parentheses mean? Yeah, that's what we're plugging in. So let's first rewrite the whole function. So that equals 31.572 x. So instead of x, I'm going to write parentheses 6.2 minus 17.741. Now, order of operations says we have to do what first? Parentheses or multiplying, right? So let's find 31.572 times 6.2. I got 195.7464. Is that what you guys got? 7464. Let's write it all down right now, and then we'll estimate at the end. Minus 17.741. Okay, and then you're going to subtract 17.741. So you end up with what? 178.0054. In the book, it leaves it like that. So I guess let's just leave the whole thing. Especially since our function had 1, 2, 3 decimal places, so we can leave it. Okay, so then part B wants us to use the same function, but this time we're going to plug in negative 27.018. So let's plug it in first. I ran out of room, so I'm going to rewrite underneath. That's going to be 31.572 times negative 27.018. Remember, that's how I want you to show your work. Minus 17.741. Let me remind you guys how to do the negative on your calculator. So if everybody looks at the calculator, we have negative 27.018. So let's do that first. So type in 27.018. To make it negative, we need to find the plus or minus symbol, which is in the corner, right here. So then press that, and that turns into a negative, times 31.572 equals, and write that number down. So that comes out to negative 853.012296 minus 17.741. And so then take exactly what's on here, don't change anything, and just type in minus 17.741. And we get this whole big number. So I think we'll definitely have to round there. So that's going to give us negative 870 point. Let's do, because everything that we plugged in was to 3 decimal places, let's do it to 3 decimal places. So 0.753. And that's your answer. Okay. So I chose 3 decimal places because everything we plugged in was to 3 decimal places. Okay, also in this unit we had inequalities. We solved, and then we also graphed our solutions to the inequalities. The thing about inequalities is that solving is very similar to solving equations. The only thing we have to be aware of is if we multiply or divide by a negative, the inequality flips. So we need to be aware of that, but otherwise your steps are pretty much the same. Okay, so remember when we were solving, your first step was always to distribute and then combine like terms. Do you guys see distribute or combine like terms? Yeah, the -4, right? So distribute the -4. So that gives me negative 4x minus 4 greater than or equal to 12. And just like always, we want to try and get the x by itself. So what would you guys do next? Add 4. So add 4 to both sides. Remember, adding 4 does not change the direction of the inequality. So that's going to be negative 4x greater than or equal to 16. And our last step to getting x by itself would be to do what? Divide by -4. Now, in this case, I'm dividing by a negative, so what happens? The inequality flips. So it's not greater than or equal to anymore, it's going to be less than or equal to. And remember, the reason behind that was because the negative takes the opposite value of everything. So we have to take the opposite of everything. So what would 16 divided by -4 give you? -4. So our answer is x less than or equal to -4. So that means that any x that's less than or equal to -4, when you plug it in, will give you a true statement in the original problem. So to graph that, we are going to graph on the number line. So we need to label some points. Where do you guys want to start? What if we do like 0 right here? So 0, 1, 2. This would be -1, -2, -3, -4, -5, -6, -7. So draw your number line. Okay, so if x has to be less than or equal to -4, am I going to put an open dot there, or do I get to put a closed dot? Closed dot, because we can equal that point, right? So the closed dot means you can touch that point. Open is like a fence. You can get really, really close, but you can't get to it. But in this case, because it has the equal, we get to put the closed dot. And all the x's have to be less than or equal to -4. So which direction do the x's get smaller than -4? To the left or to the right? To the left. So you're going to draw an arrow to the left. And that's how you would graph your answer. Okay, guys. So a compound inequality means that we put 2 inequalities together. And remember, compound inequalities could either be and statements, meaning we're looking for one and the other, so you have to put both your answers together. Or it could be or statements, meaning that either one or the other is true. You guys know that those commercials for, are they Ford, where they're like, nuts and bolts is better than nuts or bolts? You guys know what I'm talking about?
Oh, yeah.
Okay? And so if they're only using nuts or bolts and then their pool falls apart, and so nuts and bolts is better. It's the same kind of idea. If your word is and, like it is in this question, it means that you have to use both of them. If your word is or, it means you can use one or the other. So in this case, our word is and. So let's look at what happens with the graph. I have first x is less than 4. Would that be an open dot or a closed dot at 4?
Open.
An open dot at 4. So do an open dot at 4. And I'm going to draw this with my pencil first because I'm going to erase it on my... So just draw this really lightly because you're going to end up erasing a little bit. If x is less than 4, which direction does my arrow have to go? Which numbers are getting smaller than 4? To the left. So just lightly draw an arrow to the left right now, all the way. So all of those x's are less than 4. But we also have to include all of the x's that are greater than or equal to -1. So is that going to be an open or a closed dot at -1? That's a closed dot at -1. And with my pencil again, which direction is x greater than or equal to -1? To the right. So if we're looking at our answer, I have arrows going all the way to the left and an arrow going all the way to the right. My answer has to be less than 4 and also greater than or equal to -1. So where would my answer lie? In between the two. So your answer is actually the line in between the two endpoints. Because your x's have to be less than 4 and also greater than -1. So everything beyond the endpoint doesn't satisfy half of the question. So it's just the stuff in between. If the word was or, your arrows would be going in two opposite directions. So you would leave your answer going in two opposite directions. Do you guys remember this? Kind of? Okay? That's all you'll have to do is graph it. Okay? So last one, we have 2 more examples. We're looking at absolute value. Guys, what do you remember from 7th grade and elementary school about absolute value? Yeah, your answer always comes out positive, right? So number 7, we're just evaluating. So they give us all the numbers and we're just simplifying. So A is the absolute value of 4 minus 12. So absolute value kind of works like parentheses. You do everything inside of it first, and then you do the absolute value last, okay? So I have 4 minus 12. What's that going to give me? -8. So our next step would be to write the absolute value of -8, or equals. How about we do equals? And then we can do the absolute value part. So what's the absolute value of -8? Positive 8. That's all I want you to do. So really quick, do part B. So part B, absolute value of -8 times 7. What does -8 times positive 7 give you? Yeah, so this is, the next step is equal to the absolute value of -56. And what's the absolute value of -56? Positive 56. You guys should all get 100% on your homework on these. And that's 7. So the last one is to solve an absolute value. Okay, so write down the problem. Absolute value of 2x minus 5, all of that equals 7. Okay, so the thing about solving the absolute value questions, in order to get an answer of positive 7 when I take the absolute value, do you guys agree that this whole inside could end up being positive or -7? Because if I plugged in an x and I got -7 inside the absolute value, after I take the absolute value of that, I would still get positive 7 as an answer, right? So remember, with absolute value, we take off the absolute value bars and we set it equal to positive 7 and -7. Remember that? So every time you have absolute value, you should get 2 answers. So let's take down the absolute value bars, and we would get 2x minus 5 equals positive 7. But 2x minus 5 could also equal what? -7. Because if I were to plug it back in, after I take the absolute value, that would give me an answer of positive 7. Now, this should be easy to solve, right? what would you do first on the positive 7 side? So that gives me 2x equals 12. And then what would you do? Yep. So x equals 6. That's one answer. How would you solve the negative 7? Add 5. Now this is where I want you to make sure you're paying attention, because this is where I see a lot of arithmetic errors because you guys are just going so fast. 2x would equal, what's negative 7 plus 5? Negative 2. And then when I divide by positive 2, I get x equals what? Negative 1. So our two answers are x equals 6 and x equals negative 1. You get two answers for absolute value. If I were to plug either of these back in for x, I would still get positive 7 as my answer. Okay? All right, so Unit 3, we were solving equations. Unit 3 was the graphing. Remember how we were graphing in slope-intercept form and standard form? Y equals mx plus b and all that good stuff. So at first we started with looking at word problems and writing equations and solving those equations. So here's your first example. Holly has $150 to spend at the mall. She decides to buy sweaters and pants with her money, and then it gives you some information. Sweaters cost $35 each, and pants cost $20 each. You don't have to write this, but I'll underline what I do want you to write. Your question is to write an equation that represents this problem situation. S is the number of sweaters. So I just want you to write S equals number of sweaters. You can use whatever abbreviation you want. Just in part A, write S equals number of sweaters. P is going to equal the number of pants. So you don't have to write it in words like this. You guys can write it like we did on the posters around the room, but you do have to define your variables. Okay? So S is number of sweaters, P is number of pants. So to write this equation, we want the number of sweaters she buys and the number of pants she buys to equal $150. So to write out the cost, how would we represent how much her sweaters in total cost? 35S, good. Make sure your S doesn't look like a 5. Make sure your 5 doesn't look like an S. Okay, and then she's also buying pants. How would you represent how much her pants cost? 20p. And if we're buying sweaters and pants, Brittany, what would you do to those two? Add them. And we want the whole thing to equal how much? $150. So that's your equation. We did this a lot with systems of equations, right? So this shouldn't be too bad now that we're going back to it. That's all you had to do for part A. Now, part B says, if Holly buys 3 sweaters, what is the greatest number of pants she can buy? So I know for sure that she bought 3 sweaters. So how would I plug that into this equation? So 35 times 3, and we're trying to solve for how many pants. So plus 20p, and she still has $150. Could you guys solve this for p? No? Who said no? Okay, what's 35 times 3? 105. So 105 plus 20p equals 150. And then what would you do? Subtract 105. I totally ran out of room. So that's going to give me 20p equals 145. Oh, no, my goodness. Equals 45. And then what would you do? Divide by 20. Now, 20 does not go into 45 equally. Who has a calculator? What'd you get? 2.25. Now, can she buy 2.25 pairs of pants? If we rounded this up to 3, would she spend $50 or $150, or would she spend more than that? More. So what do we have to do? Round down. So what is the greatest number of pants she can buy? 2. So write that in a sentence. Holly can buy 2 pairs of pants. I'm just going to write 2 pants because I ran out of room. But really, it's 2 pairs of pants. Okay, so now let's say Holly buys no pants. So she didn't need pants. She only wants sweaters. What would I plug in for pants then? 0. So this time we're solving for sweaters. So that's going to give me 35s plus 20 times 0 equals 150. I do want you to show this step, please. So make sure that you're showing your steps. But 20 times 0 gives me 0. So this is 35s equals 150, and then divide by 35. So somebody with a calculator do that for us. It comes out evenly to 4?
4.28.
Okay, 4.28. Okay, but if we round that up to 5, she would spend more than $150, right? So Holly can buy how many sweaters? 4. Does that make sense, guys? We're not rounding down because the 2 is smaller than 5. We're rounding down because if we round it up, she would spend too much, right? So even if we got 4.75 pairs of pants, or sweaters, I mean, she still couldn't buy 5 sweaters, right? So make sure that you're reading the problem and what it's asking so that your answer makes sense. Okay, so we're going to work on isolating variables a little bit. So example 2, you're going to solve the formula C equals 2 pi r for r. Does anybody know what this is a formula for?
Circle area.
Circle, but it's not the area, circumference of the circle. So I'm giving you the formula circumference equals 2 pi r. We want to solve for r. Okay, so that I can show my work, I'm going to write it again. You guys don't have to. How would we solve for r? I have 2 pi attached to it. How is 2 pi attached to the r? Multiplied. So how would I get rid of it? Divide. So divide both sides by 2 pi. So then the 2's reduced to 1, and the pi's reduced to 1. So that leaves me with r equals capital C over 2 pi. Can I do anything else? No. Did I solve for r? Yeah. So you're done. That's all it wants you to do. Practice isolating variables. Easy, right? Okay. We have 2 more and then we're done, and you guys can have the rest of the time to work on your homework. So, example 3. Write the equation y equals negative 1/4 x plus 3 in standard form. Okay, guys. So, really quick, just as a recap, slope-intercept form is y equals mx plus b. That's what this is in right now. Standard form, remember, was ax plus by equals c. And a, b, and c were integers, right? No fractions, whole numbers. So we want to take this formula, or this equation, sorry, and get x and y on the same side, basically. So if you guys look, I have y equals negative 1/4 x plus 3. I want to move this negative 1/4 x to the other side so that x and y are on the same side. So what would you do? Add 1/4 x to both sides. So then those cancel on the right. So that leaves you with 1/4 x plus y equals 3. I really don't like that we have a fraction there. Does anybody else like the fraction? No. So how could I get rid of 1/4? Yeah, remember we multiply the entire equation by 4. So when I distribute it, the fractions will reduce out. Okay, so if we multiply the 4 and we distribute 4 to everything, 4 times 1/4, those 4's are going to cancel. So what would I be left with? 1x. Now the 4, when I multiply by the y, is going to give me what? 4y. And remember, this is what a lot of you forgot when we took the test on this. You have to also multiply the 3. What would 4 times 3 be? 12. Now we are in standard form. AX plus BY equals C. What would A be in this case? A 1. So this equation that we got at the very beginning is actually exactly the same as X plus 4Y equals 12. We just rewrote it in a different way. Okay? So the last question is actually the same thing but going the opposite way. So I give you an equation in standard form, 2x plus 3y equals 9, and I want you to write it in slope-intercept form, which was y equals mx plus b. So guys, this is why I had you start with solving for r in example 2, because we want to solve for y now in this case. So that means I need to get x to the other side. So what would you do to move 2x to the other side? So subtract 2x. So then it cancels on the left, and on the left we are left with 3y equals negative 2x plus 9. But y equals mx plus b, there's nothing in front of the y. So what else do I have to do to get y by itself? Yeah, divide by 3. And remember, you divide every individual term by 3. So the 2x and the 9 are both divided by 3. So what does that give me? Y equals negative 2 over 3x plus what? Plus 3. This equation is exactly the same as the one we started with. If you would want it to go backwards, you would do exactly what we did in example 3, and you would get what you started with. Okay? So that was unit 3, guys. So we were working with equations of lines, or in linear equations, and then solving from word problems. So on your homework page for this one, I wrote on your homework log to skip number 1, also skip number 6, okay? So on the homework log, for the second set, for unit 3, it says skip number 1, also skip number 6. So you're doing, on pages 7 through 10, you're doing all of them. And on pages 11 through 13, you're skipping numbers 1 and 6, okay?